Alrighty. Page 2, Part 2 of the final review, 050. Let's bring the meters down. Of course, we're going to work with more conversions this time. It's millimeters. So the problem states, in an assembly process, a 4 millimeter hole, millimeters are pretty small, needs to be drilled. How many inches is this? So we've got to switch it, 4 millimeters to inches, and we got to use scientific notation. So let's first convert it in standard notation. 4 millimeters to, we want inches. And how many inches are in a millimeter, or vice versa? And this one's given to you. It's 1 mm equals 0.03937 inches. That's a pretty lengthy conversion. Well, let's deal with it. That's given, so we'll work with that, and then we'll round it off later. So what you got here is 4 millimeters. So you set it up, if you remember, over 1, and then we're going to multiply by with the millimeters on the bottom. So that's going to be our cancel. So and then it's the 0.0. I'm going to drop that front 0. 7 inches. So what does that mean? So take out your trusty canceller. So basically we're multiplying 4 times 0.03937, and the answer will be in inches. All right. So the answer with your calculator is 0.15748. So there's our answer, and then, but we have to put that in scientific notation. So round to 2 decimal places. It does say decimal places. So it's a little weird that it says that. It should really say round to 3 significant digits. Because 2 decimal places beyond the whole number, it's not totally clear, that question. So, but let's look at that. Go to another page. That 0.15748, well, you know, in scientific notation, you're going to do times some power of 10, and the number in front has to be between 1 and 10. So we'll just move that decimal place over 1 place. So since it moved once, put a 1 over there. So, oops. Is that right? No, that would be 1. That would be 15. So if you want to move it the smaller, when you do move something, if you're going to make this bigger, you got to make you've made the number bigger by going from 0.15748 to 1 point. So you got to take it back, which means that's a negative 1. And you know, that idea of negative exponents, fractions, and decimal numbers smaller than 1 are fractions. So, but then again it says round to 2 decimal places, which I assume that to mean that. Like the 100th place in the front. So times, you could use a dot there in front. That stays the same. We're just rounding this baby up. And there's your answer. All right, moving right along. This is number 7. This is another conversion type mixed with scientific notation. And we're talking, these are the 2 numbers we're working with. And as usual in these problems, I'm going to multiply them or am I going to divide them? Which is it? So one way to do it is to say, okay, I've got this sesame seed that's got this inches. I'm just going to go 5 times 10 to the minus first inches over 1. That's how much that sesame seed, how big that is. And then what we want to do is figure out, so what do we want? We want to cancel out the inches and figure out how many grains of salt. And if you want to be cool for salt, you can put NaCl That's the chemical equation for it. The compound. So let's see. And what is that? That's where you get the 7.5 times 10 to the minus third is in 1 grain. So 1 grain is that. So you're really saying, oh yeah, so that means we're dividing, because the inches are going to cancel. And then it's a division problem. 5.5 times 10 to the negative 4 divided by 7.5 times 10 to the negative 3 to figure out how many are inside each other. Now, how do you do this? We need another page for that. Now, I'm going to work with this, keep it in standard notation. But another way to do it is just to change them to standard. By this one becomes 5.04, 0.5, and then this one will move over 3. 1, 2, 3. Oops. So that would move over 3. Why is it doing this cut thing? So you go 1, 2, 3, so with 2 zeros. So you could just do that. Put it in your calculator and work it that way. See what you get, and then change it back to, now it says round to the nearest whole number. Well, let's see what we got. But I'm not going to do that. Even I showed you that. Wouldn't be wrong. You should get your full credit. So I'll get rid of those yellows. And the way to deal with this is, let's look at this here and basically just divide this stuff. And then we'll deal with the exponents in a minute. So it's 5.014 divided by 7.545. And what do you get? You get 0.664546, and it keeps going. And that should be plenty, take it to there, because it does say round to the nearest whole number. And I'm saying that doesn't look close to a whole number yet. But then you look over here, this part, and that's, how do you do division with exponents? And if you remember, with the x's, this is just with tens, you subtract them. It's going to be 10 to the minus 1 minus the bottom one, negative 3. Oh, so what happens is these two guys become plus, so you get this times 10 squared. So this here number is going to be times 10 squared, which basically means move the decimal places 2 places bigger, which becomes 66. Whoops, let's go to that other color. It's better. 66 it becomes, because that does move it over. Whoop, whoop. And it's 66.45, blah, blah, but it says round nearest number, so get those. Just you can get these the heck out of there. And the answer is 66 grains of sand. I mean, not sand, grains of salt. Take it with a grain of salt. 66 of them. So that's how many grains of salt can fit on a sesame seed. It seems like you could fit more than that on a sesame seed, but in reality, I mean, these problems are supposed to be reality-based, but I feel like I can get more than 66 grains, unless the salt's really big chunks. I guess that's how you define how big is a grain of salt. All right, moving right along. Here we have a square, or what's supposed to look like a square. Illustration may not be drawn to scale. So here we have a square, and the perimeter is 52. Great. What's the length of each side? Now, if you know a square, and I know you do, these guys are all the same. We don't know what they are. You can sort of see, oh, there's 4 of them that make 52, but if you really want to do it algebraically, it's 4 of those, x plus x plus x plus x. I know you love to do it algebra, but algebra makes sense, really. It's what you really know. It's just sometimes it's hard to write it out. So those 4 make that, and then, oh, x plus x plus x plus x is 4x. And then what do you do to solve for x? Why, you divide by 4. So the answer is x is 13 inches. Easy. Cake. You could do it also, just say, oh, there's 4 of them. You could plug in 10, 10, and 10, and 10. Not enough. 11, 11. You know, you can keep plugging and chugging until you get it. But I think you innately know about the this idea of 4 of these things. So this whole thing over here is really just, that's just the algebra way of representing it, of what you probably do in your head, not so stepwise. Okay. Now we're on to number 9. What's going on here is we got a square again. They give us the perimeter, 60. So we do the same thing to figure it out. And then we're supposed to add x to each side and represent the new perimeter. So same way, if this was x, I'm not going to call it x though this time. Because I hear there's an x coming in later. But I know these 4, let's call them 4 s's, give you 60. Same deal though. Divide by 4, divide by 4, s is 15 inches. So each side is 15. Cool. And then we are going to add x to each side. Increased means add, not multiplied. If it's a double, then you'd multiply it, or 2 by 2, or product means multiply. This is increased by. Just add up an x. Everybody gets an x. And what you get, let's get a little messy. That's what you get. What would you get? 15 plus x plus 15 of x. And if you want to be cool, I know you do, too cool for school, that's going to be our new perimeter. Our new p, pleasant p. Let me section this off a bit. It's getting a little hard to read. So this guy, there's just 4 of them. Can you leave it like that? I suppose you could, but it's generally you want to work stuff out, simplify it. Simplify basically means get rid of the parentheses. And when you factor, you're actually going the other way. You're making it less simple. So when parentheses are involved. So I'm going to go ahead and take it that next step, which is 4 times 15, the old distributive. There's your 60 plus 4x, which totally makes sense to me and to you too, because there's the 60 from the original. You added x to each side, and there you go. So you're adding 4 x's. So you didn't even have to find the 15. You could have stuck with the 60 and said, I'm adding x to each side, so that's plus 4x. And there you have it. Alrighty, here's number 10. And this one's a little involved. Company A rents copiers for $180 plus 12 cents per. So here we're getting a linear equation business, where there's over here is kind of like the slope. It is the slope, it's that rate. So it's 12 cents per x, and this is like the y-intercept, or the fixed amount, the original amount, initial amount, all the same thing. So change the order a little bit, just because that's the way they said it. But you could put 0.12x if you want. If you want them to, there's your slope, and there's your y-intercept. Except that it's not really y-intercept, it's your a-intercept, the amount that a makes. So there's the first equation. B, similarly, is 360. I'm going to put that in the back this time to look like A. So B, and then they charge 6 cents a copy. Just make sure when you do 6 cents, it's 0.06. Because over this is dollars. So this has to be in terms of dollars too. All right, there's our 2 equations. How many copies would you have to make in 1 month in order to be charged the same rental by both? So basically, we want the A and B, those guys to be equal. So if A equals B, then their equations should equal each other. So let's go to the next page. What we have here is the 12 cents a copy plus the 180 is equal to the 6 cents a copy plus 360, the cost of B and A. We want them to be the same, so just set them equal to each other, and then you got your solving ahead of you. So how do you do that? X's on one side, numbers on the other. These X's here is the 0.12 is bigger than 0.06, so I'm going to keep it on the left, because I like to do that. I like to keep my X's positive. So when you subtract it, subtract your x's, what you get, is 0.06x plus 180 equals 360. You eliminate on the left, and then you do the other, swing it the other way, which is take away 180, take away 180, and just take away enough. You don't have to put that line there, but sometimes it makes it easier to see. We got a .06 on the left and a 180 on the right. Last step, boom, divide by .06, divide by .06, and that takes a calculator. Or not. I know 6 goes into 180, 30, and then there's this idea of two places, and there is. But do it to calculator, and you get for a grand total of 3,000, which really is 3,000. 3,000 copies will put you at the same price. And if you don't believe it, just plug it in and see if you get the same thing on both sides. All right? And by the way, if you did plug into 3,000, what you wind up getting is, I'll put this over here on the left, it would cost $540. With A's plan or with the B plan, same thing, $540 to make 3,000 copies. All right, the last one on page 2 is a certain stock. Number 11, these can be, I know people get confused by these. What you do, you start them with X. Just do what it says. It's worth X dollars the beginning of the month. By the end of the first week of that month, it's doubled. Woohoo! 2X. That's what double means, times 2. Then decreased by 2. And it just says $2 per share. That just points our dollars in stock talk. So there is our new amount per of the value of the stock at the end of the week. And then they say, well, what is the value of your stock at the end of the week if you own 20 shares? Well, this is the price, or value, I should say, of one. I'll write that out. Of one stock, one share, you got 20 of them. So just do 20 times that. It's as easy as that. There you go. And then let's simplify it. Because how much money is that? Well, I don't know what X is. I don't know what it started with, but at least I can multiply this. There's 40X. The old distributed property. There it is. 40X minus 40. That's the value. And what's that measured in, by the way? You know it. Dallas. Texas. All right. There you go. We're done with page 2, part 2. On to 3.